Welcome back, everybody. In this episode, we're going through the OSI model, which stands for Open Systems Interconnection. This model describes how information from one software on one computer moves through the network and reaches software on another computer. To make that process easier to understand, the OSI model breaks everything into 7 layers, and each layer controls a specific part of how data is sent and received. Let's walk through each layer from the bottom up. So layer 1 is the physical layer. Layer 1 deals with how raw bits of data, those ones and zeros, are transmitted through physical media. This includes things like cables, connectors, and electrical or optical signals. It also defines the topology of a network, meaning the physical layout of how devices are connected. Now, layer 2 is the data link layer or data link. Layer 2 takes the raw bits from the physical layer and organizes them into frames. Now, a frame is raw data that's been properly formatted by adding headers and trailers so it can travel across a local network. One of the headers added to this layer contains the MAC address, which is the unique identifier every network device uses to identify itself. This is also the layer where switches operate. A switch reads the MAC address inside a frame and uses it to determine where the frame should go. In other words, switches connect devices on a local network and forward traffic based on MAC addresses. Now, layer 3 is the next layer. This is the network layer. Layer 3 is responsible for routing data across different networks using IP addresses. At this layer, data is broken into smaller chunks called packets, and each packet is sent with instructions on how to reach its destination. Devices can operate at layer 3 include routers and layer 3 switches. The next layer, layer 4, is the transport layer. Layer 4 provides the actual transfer of data between end users. It uses two main protocols, TCP and UDP. Now, TCP ensures reliable delivery. It resends any packets that don't receive an acknowledgement, reassembles data in the correct order, and performs error checking. UDP also transfers data, but it does not guarantee delivery. It's faster and is commonly used for applications like video streaming, where speed matters more than perfect accuracy. The next layer, layer 5, is the session layer. Layer 5 controls the dialogue between devices. For example, if two people are on a video call, the session layer is responsible for starting that communication, managing it while it's active, and ending it when the call is finished. It essentially directs the flow of network traffic between devices during a session. Coming up next, layer 6 is the presentation layer. Layer 6 is responsible for translating data into a readable format before handing it off to the application layer. This is where data is compressed or decompressed and encrypted or decrypted. Because of this, it's often referred to as the translation layer. Layer 7 is the application layer. Layer 7 is the layer that we as people actually interact with. It deals with the application and protocols we use every day. Things like email, HTTP for web browsing, and FTP for file transfers. At this layer, the data resembles something readable or recognizable to the user. Now, that is it for the OSI model from the bottom to the top, or top to bottom, however you look at it. Layer 1 through layer 7. Now, understanding these 7 layers gives you a clear picture of how data moves across a network and helps you troubleshoot issues more effectively. Thanks again for listening. Stay sharp, stay consistent, and let's keep moving forward, one concept at a time.